Okay, our next component is actually a rubber tire. This is a bisplat tire. It's not a steel belt radial. There is no trick involved in this. Okay, our first question is, a rubber tire is an absolute insulator. That is incorrect. Okay, now one thing we're going to do, we're going to test this with a digital multimeter, and you notice that we've got it set on voltage. 20 volt scale, DC volts. Okay, now we're going to go ahead and check output from our power supply. Oops. God damn, where's my, oh yeah. We have 13.92 volts. Okay, so that's the output from power supply. Now, what we're going to do, and all we have is a ground coming from the power supply over to the inside of the tire, like lug bolts or lug nuts on a tractor. And you can try this on a tractor, you can try it on an automobile, pretty well any vehicle. The reason I had to use this is because the bearings in here, they were ball bearings, roller ball bearings, and they had a little bit there packed with grease, so that was insulatory material. So I wasn't getting the correct conductivity that actually we're trying to display. Now the next question, testing with DMM from the battery positive, and that's what we have going to our multimeter, to the tire, to the outside of the tire. The voltage is displayed due to electromagnetic transfer. Okay, you'll notice that when we go to the outside of the tire, to the tread, we're displaying approximately 13.41 volts. That's to the rubber. So we are getting conductivity, but it is not due to electromagnetics of any type. There's no electromagnetic transfer. Okay, the next question, the concentration of carbon black will determine conductivity. That's correct. The composition of a rubber tire. Think about how this is made. Now, rubber in its natural state, when it comes from a rubber tree, after a short period of time turns rock hard. Now, the composition of the rubber of this material is, you have multiple polymers and carbon black is added. Now, carbon black is partially for rigidity, but think about it, carbon is also a common resistor. That's what common resistors are made of. So essentially you have a resistor right here. This is actually a complete resistor. Now the conductivity of it, as far as amperage delivery capabilities, is minimal, but you can read stagnant voltage, and that's why when we go from there to here, we're reading 12.5 to 12.8 volts. Now the next question, voltage indicators due to natural density of rubber. Now there again, rubber, when it is taken from a rubber tree, and there is such a thing, within a short period of time it turns into rock, but it is a true total insulator. There is no conductivity possible with that. Now the next question, with carbon black in composition, this is similar to a resistor in an electrical circuit. That is absolutely correct. There again, carbon black, carbon, and a carbon resistor, you will conduct electricity, but think about like a resistor in a hydraulic system is an orifice. But you can, this is resistive. Now one thing we'll note is we'll look over here. 13.1. Now if we go real close to the rim, 13.78. The closer we get to the ground, the less the resistance, less carbon of which we must pass through. So, and we go to the valve stem, let's try that. 13.67. There again, you're closer to the ground. So the ground path is much shorter, much less resistance. So that is all we have on that